everyone, this is Tanishri NR studying Electronics and Communication in Sri Venkateshwar College of Engineering. Today's our topic is Addressing Mode. Introduction. Addressing mode define how a CPU accesses data from memory. They specify the location of operands or data within the computer's memory. Different addressing modes offer flexibility and efficiency in programming. Immediate addressing mode. In immediate addressing mode, the operand is directly specified within the instructions. It is useful for constants or small values that do not need to be stored in memory. Example MOVA #10 loads the value 10 into the register A. Direct addressing mode. Direct addressing mode accesses data directly from the memory address specified in the instruction. It is simple but limits flexibility as the address is fixed. Example MOVA 2050 loads the content of at memory addresses 2050 into register A. Register addressing mode. Register addressing mode involves specifying a register as the operand. It offers fast access to the data stored in registers. Example add A B. B adds the content of register B to register A. Indirect addressing mode. Indirect mode access data indirectly through the memory address stored in the register. It provides flexibility as the memory address can be changed dynamically. Example MOVA. B loads the content at the memory address stored in register B into register A. Indexed addressing mode. Indexed mode adds an offset to the base address specified in a register. It is useful for accessing elements in arrays or data structures. Example MOVA. B plus X loads the content at the address B plus X into register A. Relative addressing mode. Relative mode accesses data at the memory location relative to the current instruction. It is often used for branching instructions. Example JMP $5 jumps to the memory address 5 bytes after the current instructions. Stack addressing mode. Stack mode involves accessing data from the stack data structure. It uses a stack pointer to keep track of the top of the stack. Example PUSHA pushes the content of register A into the stack. Base register addressing mode. Base register addressing mode uses a base register to specify a base address for memory access. It simplifies addressing in programs with multiple memory regions. Example MOVA base plus offset loads the content at base plus offset into register A. Memory indirect addressing mode. Memory indirect mode uses a memory locations to store the address of the operand. It allows for complex addressing calculations. Example MOVA B loads the content at the memory address stored in memory address B into register A. Auto increment and auto decrement addressing mode. Auto increment mode automatically increments the address after accessing data. Auto decrement mode automatically decrements the address after accessing data. These modes are useful for iterating over data structures. Scaled addressing mode. Scaled mode involves multiplying an index register by scaling factor. It is commonly used in array operations where elements are of fixed size. Example MOVA B plus X. Unique to 80386 Core 2 microprocessors use two 32-bit registers. to access the memory. The second register is multiplied by the scaling factor. The scaling factor can be 1x, 2x, 4x, 8x. The scaling factor of the implied and need not to include in the assembly language instruction. Addressing mode selection. The choice of addressing mode depends on the specific requirements of the program. Programmers must consider factors such as efficiency, flexibility, and ease of use. Different addressing modes can be used within the same program to optimize performance. Summary. Addressing modes play a crucial role in determining how data is accessed in the computer system. They offer flexibility and efficiency in programming by providing various ways to specify operands. Understanding and utilizing different addressing modes can improve the performance of the programs. Thank you.